Okay, so today we're going to look at nuclear physics. Okay, and the first part of it is called radioactive decay. Okay, and so as I gave yesterday in the briefing, there are three types of radioactive decay which we will have to look at today, which is the alpha decay, the beta decay, and the gamma decay. So each of these decays are different in terms of their characteristics. Okay, and we will look at how different they are, and then after that later we will look at how they contribute to to radioactivity as a whole lah. All right, so whenever we talk about radioactive decay, we have to remember that radioactive decay only happens in a radioactive substance. Okay, so not all substances are radioactive by nature, but there are some substances, okay, that are more radioactive than others. Okay, and so the more radioactive your substance is, okay, the more likely it is to decay. Okay, technically speaking, all of us are radioactive as well because there's always a little bit of us that is always decaying lah. Okay, we have skin cells that fall off. Okay, we have hair that drops off and things like that. So actually, we are still decaying ourselves. Okay, but when we talk about radioactive decay, of course, we're referring to like radioactive materials lah. Okay, so especially certain materials, certain elements which are especially more radioactive because they produce these rays, okay, which is alpha ray, beta ray, and gamma ray. Okay, so it's quite easy to remember lah. Alpha decay, okay, will produce an alpha ray. Okay, beta decay will produce a beta ray, and gamma decay will produce a gamma ray. Okay, very natural lah. Okay, so of course, the first thing we need to remember is that in any atom, okay, in any atom, whether it is a radioactive substance or a non-radioactive element, okay, we have to remember that in the nucleus of an atom, okay, there are these two things which are called the protons and neutrons. Okay, and of course, the electrons are orbiting around the nucleus lah. Okay, but radioactive decay is a process, okay, where an unstable nucleus, okay, becomes more stable. And how does it become more stable? It does it by emitting radioactive radiation, sinaran radioactive. Okay, so that is what radioactive decay is. Okay, reputan radioaktif okay, is daripada nukleus yang tidak stabil, okay, nucleus okay, where the protons and neutrons are not stable becomes more stable, and it does it, okay, by emitting radioactive radiation. Okay, you can think about this as like for example, a volcano lah. If a volcano is not stable, okay, what does it do? It erupts, and it erupts, and then it lets go of this one, so that it becomes more stable after that. Okay, of course, there are many other examples that you can also use lah. Okay, but generally, I like to talk about volcanoes. It's the easiest for us to imagine. Okay, but the thing about this is this lah. Just like volcanoes, the process of radioactive decay is very random. Okay, dia sangat rawak. Okay, and dia sangat spontaneous. Okay, very spontan. Okay, then rawak means you cannot predict. You cannot really predict when or where it's going to happen. Okay, because it is not influenced by temperature, pressure, or other physical factors. Okay, there are things going on inside the nucleus. Okay, that cause the decay to happen, but it is not caused by external factors. Okay, dia bukan daripada faktor luar. Oh, terlalu panas, then you become, it will start to decay lah. Okay, dia bukan macam orang yang orang yang kamu tolak, bahkan how sometimes if you keep pushing somebody, okay, after a while they will just break lah. They will just break and then they will just decay. Okay, but that is an outside factor. But in the case of nucleus, okay, in the case of radioactive decay, the reason why we call it random and spontaneous because we cannot really predict it. We cannot say like, okay, let's put this nucleus under the sun. Okay, will it decay or not? Actually, we don't know. We don't know. It may decay, it may not. Okay, but the point is that it is random and spontaneous because it cannot be influenced by outside factors. Okay, as like temperature, pressure. Okay, so that's why, again, as I mentioned yesterday, this is a branch of modern physics. Okay, classical physics always talks about okay outside factor, and then after that dia akan mempengaruhi inilah. But modern physics, okay, doesn't take into account outside factors. Okay, as I said, there are things going on in the nucleus that causes this decay to happen. Okay, but it's so hard for us to predict. That's why we call it random and spontaneous. Okay, now the three types of radioactive radiation or radioactive rays, okay, sinaran radioactive, okay, there are three types lah, which is the alpha particle, okay, there is a beta particle, and there is a gamma ray. Okay, notice that when we talk about alpha and beta, it is a particle, means ada sedikit unsur yang keluar. But if it is a gamma decay, only a ray comes out. Satu sinaran saja yang keluar. Okay, but the process is still the same. Whether you're emitting particles or whether you're emitting a ray, okay, the idea is that it is going from a non-stable nucleus to a more stable nucleus. Okay, again, sorry, not again. Let me remind you that sometimes it is just going from a less stable to a more stable. But that doesn't mean that the more stable one is already stable. Sometimes dia kena mereput beberapa kali sebelum dia menjadi like totally stable lah. Okay, so it's just going from a less stable to a more stable condition. Okay, sometimes it can be totally stable, but sometimes it's just more stable than previously lah. Okay, so here's another gambar raja to show you. Notice that in terms of the size, the alpha particle is much bigger compared to the beta particle. Okay, even in these two diagrams, you can clearly see that the alpha particle is much bigger, much heavier, okay, compared to the beta particle, and the gamma decay only produces a ray. Okay, so in terms of the characteristics of the tree, okay, so the first thing we need to know is that the alpha particle actually is a helium nucleus. Okay, so the reason why we call it alpha is just to give it a name, but actually apakah particle yang keluar itu adalah satu nucleus helium. Okay, with a mass, with nombor jisim, with a mass number of 4 and atomic number 2. Okay, so I hope you know what I'm talking about when I'm writing this, because it's chemistry lah. Okay, so this is helium 42 lah. 4 is the mass number, 2 is the atomic number. Okay, a beta decay produces a beta particle. And what is a beta particle? A beta particle is a high-speed electron. It is just an electron, okay, that is produced. So that's why if you look at it, if you just look at these two conditions, you know that the helium nucleus is way heavier, okay, compared to an electron. If you remember your chemistry, okay, the mass of the proton and the mass of the electron is very different. Okay, the mass of the electron is very small. Apalagi kalau dalam proton itu ada 2 protons and 2 neutrons. It's very heavy. Okay, that's why you see this picture over here. There are 2 protons and 2 neutrons. Manakala the beta particle is just an electron. Okay, so this part of this chapter is actually very easy lah. Alpha decay produces a alpha particle. Beta decay produces a beta particle. Gamma decay produces a gamma ray. Okay, which is what we are going to in this one lah. The gamma ray is actually an electromagnetic wave that you studied last year in chapter 5. Okay, remember when you did the Google site for the chapter 5, okay, there was an electromagnetic wave. Right? So gamma ray is one of the electromagnetic waves. And it's just a wave. Okay, it's just a wave, that is just produced, okay, to make the nucleus more stable. Okay, now in terms of the mass, this is the relative mass. The alpha is about 4, okay, because there are 4 particles in there, like 2 protons and 2 neutrons. Okay, the electron is very light, so the mass is about 1/2000. And gamma, because it is just a ray, okay, there is no mass. Okay, there is no particle that is being discharged. Okay, so it's just a ray. Okay, the alpha, in terms of the charge, okay, because the nucleus helium has 2 protons and 2 neutrons. Therefore, we can conclude that the alpha particle's charge is positive. If the beta is an electron, we know that electrons are negatively charged, so the beta particle, okay, is negatively charged. Okay, and since gamma is just a wave, okay, it's just a wave lah. Okay, gamma ray is just a wave, it will be neutrally charged. Now this is very important because the charges will tell us that it can actually kena bengkok lah, it can actually be terpesong. Okay, but depending on what are the plates that you are given lah. Okay, we'll talk about this in a while. Okay, in terms of speed, this is easy. Look at, and it, and we can talk about it in terms of classical physics lah. This one, the mass is big. Electron, the mass is like super small, 1/2000. So obviously the speed of alpha will be low. It will be very slow compared to beta, which is about 90% of the speed of light. And gamma, because it's massless, okay, it is definitely traveling at the speed of light. Okay, the speed of light now is 3 times 10 to the power of 8 meters per second. Okay, that's 30 million meters per second. That's how fast light is traveling. Okay, so alpha, because it is so heavy, it's so chock full of 2 protons and 2 neutrons, it will be slow lah. But we're not talking like tortoise slow lah. Okay, we're talking about, it's still fast compared to us, but compared to beta and gamma, it is very low. Okay, the speed is very low. Okay, ionization power. The ionization power of alpha is very high. Okay, ionization power means its ability to ionize the air around you. Air around, okay, let's say for example, if this is the air, okay, that is around the helium lah, okay, so ionization power is the power of this nucleus to menjadikan the udara di sini bahkan either positive or negatively charged, like makes it become an ion. Okay, so and when the air becomes an ion, then there's a little bit of charge there lah. So the ionizing power of alpha is very high because it has 2 protons. So it is able to tarik the electron from the air to make the air positively charged. Okay, because it will have to take the electrons. The alpha particle is taking the electrons from the air. Okay, and because there's 2 protons doing this job, okay, and protons are pretty heavy, so the ionization power is high. Okay, it can really ionize the air lah. Okay, beta is not as good as alpha because it's just 1 electron, and so we call it medium. Okay, medium ionization power. It can ionize the air, but not as good as alpha. Gamma, on the other hand, because it is neutral, okay, so the ionization power is very low, if not zero lah. Okay, because it's neutral, it just cannot ionize the air lah, because there's nothing to tarik the positive charge of the air. Okay, now in terms of penetration power is kuasa penembusan lah. Okay, it really has to do with the speed. If the speed of the particle is low, the penetration power is also low. Susah dia mau tembus. Okay, sebab dia sangat slow. Okay, beta, on the other hand, since it's moving at a 90% speed of light, the penetration power will be medium. And gamma, since it is moving the fastest, is moving at the speed of light, so the penetration power will be very high. Okay, sorry, spelling mistake. Medium. Okay, so ionization power and penetration power of alpha, beta, and gamma are opposite to one another. Okay, so penetration power has to do with the speed. The faster the particle is going, the faster the ray is going, the higher the penetration power will be. Sebab dia bergerak dengan sangat laju. Okay, sure boleh tembus lah. Okay, now in terms of what it can be stopped by, okay, an alpha particle can be stopped by a piece of paper. Okay, so let's say you put a piece of paper or you cover the radioactive substance with a piece of paper, okay, and if it decays and it produces, okay, or okay, or it discharges alpha particle, it will be stuck inside the paper. Okay, dia tidak boleh tembus itu kertas lah. But the beta and gamma dia masih akan tetap tembus. Okay, so let's say for example this is the paper and this is your radioactive substance in here. Let's say bila dia decay then you got alpha, okay, and you got alpha, but the beta will be able to penetrate the paper and the gamma will also be able to penetrate the paper. The alpha will be stopped by the paper. Dia tidak boleh keluar daripada paper tersebut. Okay, beta on the other hand cannot be stopped by paper, but it can be stopped by a piece of aluminium. Okay, so if you balut the radioactive substance with aluminium, then you know that the only thing that can come out is gamma ray. Okay, you cannot have beta ray or alpha ray come out. Okay, and gamma ray it can only be stopped by lead. Lead is keluli. Okay, keluli. Okay, so if you really want to, that's why when we store radioactive materials in a box, we don't have a cardboard box lah or a gift box lah where you want to give present to your friend. No, we usually keep our radioactive substances in a box of lead. Okay, dalam satu kotak yang diperbuat daripada keluli lah. Okay, so that in case got alpha, beta and gamma, in case got gamma lah especially, because alpha and beta can be stopped by lead, definitely. Okay, and gamma, sorry, alpha and beta can be stopped by paper and aluminium lah. So what is lead lah? Come on, lead is like so super tebal and so strong. Keluli bahkan. No, actually keluli is not steel. Sorry, not this one. Plumbum. Lead is plumbum. Sorry, my mistake. Okay, so lead is plumbum. So so usually boxes or tong yang digunakan untuk menyimpan bahan radioaktif is usually made of plumbum, because plumbum has proven very effective to stop all three. Can stop alpha, can stop beta, can stop gamma. Okay, what happens if you want to transport the radioactive material and you only carry it in a plastic bag? Okay, in a plastic bag only lah. Okay, so probably you can only stop alpha, but everybody around you and also you yourself will probably die lah because of the beta and the gamma emission. Okay, can be beta and gamma ray can definitely tembus the plastic bag. Okay, now next thing is, can it be deflected by electric and magnetic field? Okay, obviously for alpha it can be deflected because it is charged, it is positively charged. Okay, sorry. Beta, okay, beta on the other hand is also negatively charged, so definitely it can be deflected. Okay, but gamma, since it is neutral, okay, it doesn't feel any effect at all. Okay, so it cannot be deflected by the electric and magnetic field. Okay, so in this case, we find that if this is an alpha particle, and let's say you have two, this is an electric field, so this is positive and this is negative, very naturally, because the alpha particle is positively charged, so it's going to deflect lah. Dia akan terpesong ke arah the plate negative. Okay, this is a very bad representation. Actually, beta particle is just an electron, right? So if you have an electron, okay, that is flowing through here, it's going to be deflected, okay, to the positive terminal. Okay, but what I want you to notice also is that the alpha particle takes a very long time to deflect. Manakala the beta particle, which is just an electron, dia masuk saja di sini terus kena deflect sudah. Okay, there are two reasons for this lah. Number one, because the mass of alpha is higher, okay, dia lebih berat, so susah untuk dia terpesong. Okay, manakala the mass of electron or the mass of beta, okay, is very low. Remember, 1/2000. Okay, so it's very, very light compared to the alpha particle. Okay, so dia senang terpesong lah. Okay, because it's very easy to, less inertia. Okay, because the mass is much less. Okay, the mass of the alpha is so much bigger, so it takes a very long time to terpesong lah. Okay, but it will definitely terpesong towards the negative plate. Okay, an electron, because it is negatively charged, is going to terpesong towards the positive plate, and it's going to, dia punya pesongan adalah sangat cepat. Okay, gamma, okay, a gamma ray, because it is neutral, okay, this is not very good lah. Okay, it's just going to go straight. It's not going to be deflected at all. Okay, because there's no charge. Okay, so let's talk about the decay. Okay, so the alpha decay and beta decay and gamma decay all correspond to the sorry, all correspond to the type of particle it is emitting. If it is emitting an alpha particle, it will be alpha decay. If it is emitting a beta particle, it will be a beta decay. If it is emitting a gamma ray, it will be a gamma decay. Okay, so when a radioactive nucleus decays, its nucleus breaks up, okay, and emits an alpha particle or a beta particle and energy. Okay, there's always energy that is, always is when the radioactive substance decays, and it forms a new atom, okay, of a different element. Okay, so a parent nuclide X changes into a daughter nuclide Y. Okay, that means after decay, it becomes something else lah. Okay, depending on the kind of decay. Okay, so for example, in this situation, so alpha particle is a helium nucleus which consists of 2 protons and 2 neutrons. We explained it just now. So during alpha decay, an unstable nucleus releases an alpha particle to become a more stable nucleus of a new element. Okay, notice that it is going from unstable to more stable. But it doesn't mean that it is totally stable, Suda. Okay, so there is a possibility for this radon 222, okay, to continue to decay again, okay, after that. But now we're just talking about one-time decay lah. Okay, so notice that radon 226, okay, radon 226 has 88 protons and 138 neutrons. That's how you get the 226. Okay, because 88 plus 138 is 226. So how do you write this? Radon is Rn. Okay, Rn 226 and 88. Okay, this is how you will write the chemical formula. Oh, sorry. It's given. Oh, radon is Ra, sorry. Radon is Ra. So Ra 22688. When it decays, and we have to specify lah, okay, it's going to decay alpha. Okay, at this stage in your physics career, okay, you're not expected to make any predictions lah. So usually a question will tell you, okay, it's going to decay alpha, it's going to decay beta. Okay, so it will tell you lah. So you have to remember, okay, if decay alpha means 4-2, okay, that means 2 protons and 2 neutrons are gone. Okay, so if 2 protons are gone, there will be 86 protons left. And if 2 neutrons are gone, there will be 136 neutrons left. Now, since the proton number is the one that determines the, hold on, Ra is not radon, Ra is radium. Rn is radon, yeah. Okay, never mind. So this is 226 radon now. Radon is Rn, yeah. Ra is radium though. Okay, never mind. Anyway, so 22286. Okay, notice that the 226 has become 222, and there is a 4 over here lah. There's a, if you balance chemical equations, left side equals to right side, so there's 4. Okay, and then this is 88, this is 86, so naturally over here is 2. Okay, and we have learned just now that 42 actually is the mass number and the proton number for helium, which is an alpha particle. Okay, which is a helium-4 nucleus. Okay, and I want you to notice also that these numbers next to it always refer to the mass number, number GC. Okay, 4, 222, 226. Okay, nobody writes radon 86. Okay, nobody writes this lah. Okay, not even in chemistry. Okay, so how would we write this in terms of chemistry? Okay, how would we write this in terms of chemical formula? We will write it like this lah. Okay, it'll be exactly like this. So the parent nucleus has a proton number Z and a nucleon number A. Oh, nombor nucleon pula kan? Sorry, mass number. Okay, after a decay, the daughter nucleus has proton number Z minus 2 and a nucleon number A minus 4. That's why it has a alpha decay. Okay, so this is the general formula for this lah. Okay, AZX, sorry, XAZ will decay and then become YA minus 4, Z minus 2 plus alpha decay. Okay, but this is the preferred method lah. Because this is very clearly seen. 226 sama dengan 222 campur 4. 88 sama dengan 86 campur 2. Left side equals to right side. Okay, so this part is pretty easy because it's just very simple mathematics lah. Plus minus plus minus. Okay, so here's another one. So you have thorium 230. This is thorium lah, TH. Thorium is 230. If it decays alpha, it's going to become 22688. And I don't know what is this one. 226 lah. 226 is radon lah kan. Tadi 226 lah. Oh, yeah. Radium. Okay, so actually this should be Ra lah. Okay, 22688 Ra plus 42He. Okay, this is the thing that needs to be included lah, which a lot of people always forget. Actually, every time there is a radioactive decay, energy is always produced. Okay, when energy is always produced, you have to write the word energy there lah. Okay, but it's just energy lah. Okay, yang paling penting is the number on top and the number at the bottom must be balanced on both sides. Okay, here's another one. Uranium 238, 92. Okay, if it decays alpha, the 238 is going to minus 4, become 234. 92 is going to minus 2, become 90. So uranium becomes thorium. Okay, TH. Okay, plus the alpha particle, which is the helium-42, plus energy. Okay, so in that respect, you can actually kind of guess what is happening over here lah. Polonium 210, okay, polonium 21084, if there's an alpha decay, all you have to do is just make sure the left side and the right side is the same number. Okay, so the bottom over here, since this is 84 and this is 2, the balance here will be 82. Since this is 210 and this is 4, you can actually immediately count lah. This will be 206. Okay, 206 plumber. Now, you are not required actually to remember all this lah. You don't have to remember, oh, kalau 84 is polonium, kalau 82 is plumber. No need lah. Okay, people will give you one. The question will give you, you don't have to really memorize this. Okay, but what you need to remember is how to balance the equation on both sides. Okay, likewise, the same thing, the uranium, when it decays to become thorium, okay, since the right side is complete, you can actually do the left side lah. 234 plus 4 will give you 238, and 90 plus 2 will give you 92. Okay, that is if there is an alpha decay. Now, generally, when the decay happens, only it's either alpha or beta, okay, and it can be plus gamma. Okay, I have yet to see a situation where, at least in Form 5 nuclear physics, I have yet to see a situation where the element itu radioactive material kan, dia decay and then sekaligus alpha beta yang keluar. Okay, jarang berlaku macam tu lah. Usually what we usually teach is either alpha atau beta. Tapi dia mungkin bergabung dengan gamma. Okay, because gamma dia tidak melibatkan perubahan. It's just ching, satu ray saja macam tu lah. Okay, so it doesn't really involve a change. So it can be mixed with gamma, but generally decays, only one of the three yang keluar lah. Notice that in this equation also, there is the word energy that is missing. Okay, make it a point to always write the word energy in the equation of your this one. All right, let's go to beta decay. Now, as I said just now, beta particle is a fast-moving electron. Okay, and since an electron is technically not an atom, so the nuclear number, sorry, the nucleon number and the proton number will be 0 and -1 because there are 0 protons and 0 neutrons. Okay, and you know the bottom number actually refers to the proton number, right? But since there is no proton and there is a -1 charge of an electron, so this number is very special. Okay, the electron is always 0 - 1. Okay, no protons, no neutrons, but the charge is -1. So during beta decay, a neutron in an unstable nucleus decomposes into one proton and one electron. Okay, so the resulting proton remains in the nucleus while the electron is emitted with high kinetic energy as beta particle. Okay, so this is how you would do it. Okay, so the number on top remains the same before and after decay. But the proton number, dia akan tambah satu. Okay, after the decay happens. Okay, for example, this is a carbon-14 nucleus. Okay, this is a nitrogen-14 nucleus. Okay, so notice that the nucleon number, the number on top here is still the same, 14 and 14. What has changed is the number of protons. Okay, from 6 to become 7. The number of protons increase because what is decaying is the electron. Okay, so again, as I said, this is something that happens inside inside the nucleus itself. Okay, the neutron actually it is the one that decomposes to become one proton and one electron. How does this happen? Okay, is not for you to study at this moment lah. Okay, it is if you want you can do research on this. Okay, or you can wait until you go to university to study this lah. But this is basically what happens when in a beta decay. Okay, the neutron is the one that actually decomposes into one proton, one electron, and then it will gabung with the daughter nucleus, but the electron yang akan terbebas. Okay, so what happens is the carbon-14 decays by beta emission. A neutron changes into a proton and an electron. Okay, notice that this line has appeared once again, okay, to show you that this is actually a very important sentence when we talk about beta decay. Okay, because whenever we talk about decay, we always think that, oh, dia kasi buang benda ba. Okay, but in a beta decay is very special. What is actually happening is the neutron is decomposing. Okay, the neutron is neutron yang mengurai, yang terurai menjadi satu proton dan satu electron. That's why the protons increase, but because of that, the electrons have to be let go. So the electrons leave at the nucleus at high speed as a beta particle. As a proton has replaced the neutron in the nucleus, the proton number rises to 7. Okay, as seen over here lah. So this means that a new nucleus, because the proton number has changed, so the new nucleus has to be formed. So instead of carbon, which is only 6 protons, it now has become nitrogen, okay, which is 7 protons. Okay, which is 7 protons. Okay, so this is how we would write the equation. Okay, again, remember in a beta decay, the number on top doesn't change. The element changes because the proton number has changed. 6 equals to 7 plus minus 1. Okay, that's why the electron is 0 minus 1. Okay, all right. So beta decay, yada yada. Okay, this is the basic explanation lah. Okay, the proton number for the daughter nucleus becomes Z plus 1, but the nucleon number A doesn't change. Okay, and the beta particle will be E electron 0 -1. All right, so this is an example. So this is natrium, okay, natrium 11, natrium or sodium, fine. Okay, so 2411, since it is decaying a beta particle, okay, the number on top doesn't change. Okay, nombor di atas tidak berubah, nombor di bawah, nombor proton itu akan tambah 1. Okay, it will add 1. And since 11 is sodium, okay, which is group 1, 12, okay, is group 2, so it will be magnesium. Yeah, proton number for magnesium is 12. Okay, Likewise, the same here. This is carbon nitrogen. This one we discussed just now. A very common radioactive substance is plumbum. Okay, so plumbum 82, sorry, plumbum 209, if it decays, okay, and it produces a beta decay, again, the nuclear number doesn't change because 209 equals to 209 plus 0, 82 equals to 83 plus negative 1. Okay, and 83 by, I think this is Byzantium. I think so lah. Okay, I think so. Okay, so this will be a totally new element in itself. Okay, so one other thing that we need to notice is that when a decay happens, the original element changes to become another element. Okay, because dia punya proton number sudah berubah. Okay, and you know that's the pretty interesting thing about this lah. You think that kalau macam biasa lah kan, let's say for example, if for us lah, when we decay, when our skin cells drop off, we remain the same person lah. We don't change. We don't change to become an alien or something. Okay, but in radioactivity, in a radioactive substance, when it decays, produces alpha, produces beta, it becomes something else. It becomes a totally new element. Okay, satu unsur yang baharu. Okay, yang lain daripada yang originally. Dan unsur itu ditentukan oleh nombor proton. Okay, 82 is the proton number for plumbum. 83 is the proton number for, I think Bi is Byzantium. Alright? Okay, so gamma decay. Gamma rays are high frequency electromagnetic waves. Okay, and during gamma decay, an unstable nucleus just releases its excess energy. Okay, so alpha decay is releasing of alpha particle, which is a helium atom. Beta decay, the neutron decomposes, dia terurai menjadi satu proton dan satu elektron, and that electron is the one yang kena bebas. But in gamma decay, it is a release of excess energy. Okay, macam kalau kamu ada banyak tenaga yang disimpankan, you just have to okay, kasih lepaskan sajalah. Okay, so that you become more stable. Okay, like if you're very sad over something, okay, obviously you want to cry, you can't just hold it in, okay, because after a while you hold it in, you're just going to, okay, so it's good to cry. Yeah, it's good to cry. Okay, because that helps you to become more stable. Okay, it is very toxic to listen to people that say, oh, just hold it in, especially boys don't cry, all that crap lah. Okay, so yes, even in nature, okay, an unstable nucleus has to release excess energy to become more stable. Apalagi kalau manusia, kan? Okay, so gamma rays have no mass and are neutral. Okay, so they're not charged. So whenever it is being released, nothing changes in the atom. Okay, except that dia punya energy sudah berkurangan lah. Okay, it has released gamma ray as an energy. So after gamma decay, there are no changes in the proton number and the nuclear number for the nucleus. Okay, it remains totally the same. The only difference is that it has less energy. Okay, it does not change the structure of the nucleus, it just makes the nucleus more stable. And the nucleus, because it is more stable, it is less energetic, dia lebih tenang lah. Okay, you can call it is more calm after gamma decay. Okay, so gamma rays are emitted at the same time together with either an alpha or beta particle. Now, this is what I said just now. Generally, alpha and beta particle happen separately, but the alpha sometimes can result with alpha plus gamma, or it can be beta plus gamma. We very rarely hear instances where it is alpha plus beta. Okay, because again, gamma ray is just energy. Okay, so for example, this is uranium, becomes thorium, and then this is an alpha particle plus gamma energy. Okay, so this is a normal decay equation, but you also have to know a simpler decay equation. Okay, where in the arrow over here, you write down what is the kind of decay that's happening. Okay, alpha gamma decay. Okay, so it's a simple one. Either way is also correct. So during a radioactive decay, some nuclei can emit more than one radiation. For example, in the disintegration of uranium-234, the nucleus emits an alpha particle and a gamma ray. Very normal. Okay, so this is an example of a decay equation and a simple decay equation. Okay, now when we talk about decay, we need to, as I said just now, radioactive decay is a process of a less stable nucleus becoming more stable, but it doesn't mean that it is already stable. So sometimes the daughter of a nuclide radioactive stable, the daughter nuclei of a radioactive is still unstable. Okay, dia masih lagi tidak stabil. Walaupun dia lebih stabil daripada sebelumnya, tapi dia masih tidak stabil. So it will eventually decay into another nuclide which is also unstable. So they continuously decay, and the more it decays, the more stable it becomes. Okay, until finally it reaches a very, very stable nuclide. Okay? But every time it decays, it will emit either an alpha or a beta particle, and maybe gamma rays. So sometimes they can be gamma. We don't know. Okay, but for example, okay, look at this, the way this guy travels. So originally is uranium-238. Alpha decay become thorium-234. Okay, remember, just to remind you, alpha is 4, 2, this alpha. Beta is electron 0, -1. So do the math lah. Okay, 238 because it's alpha, tolak 4, tolak 2. Beta is tambah kosong, tambah 1. Okay, so it becomes this. Also unstable. Another beta. Okay. Hey, this is something wrong over here. Ha ha ha. Okay, anyway. Oh, ni silap sudah ini. This should be here. And this should be alpha. Okay, anyway. The point is this lah. It's going to go through a few decays. Okay, in order to achieve stability. Okay, and so we call this series of decays a radioactive decay series. Okay, they'll go from one to another, one to another. Okay, so for example, in this case, okay, polonium to plumbum plus S. So you have to identify for me, what is the S? Is it an alpha particle? Is it a beta particle? Is it a gamma ray? Look at the nucleon numbers to help you. If the number reduce, then you know it is an alpha particle. Okay, look at this, 40 to become 40. 19 increased by 1 to become 20. So you know that this is an electron, 0 and -1, which is a beta particle. Okay, so it's very important for us to remember that the alpha particle is a helium 42 and the beta particle is a electron 0, -1. Okay, you have to commit this to memory. Okay, nobody's going to help you to commit this to memory. Okay, so this is an example of a decay series lah. Uranium-238, yada 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 yada, all the way until finally stable at radon-226. Okay, so you are supposed to state the particle that is released in the decaying process below. Okay, so 238 become 234 will be alpha. So the number reduces by 4. 234 remain at 234. You definitely know is beta. 234 remain at 234, also beta. Because the number doesn't change, but the proton number increases. Proton number increase, no need to think, beta already. There's only 3, alpha, beta, gamma. Okay? Uranium-234 become thorium-230. Now, 234 become 230. So you know that this is alpha. 230 become 226, also reducing by 4. So it is also alpha. So in the entire series, okay, in the entire journey from uranium-238 become radon-226, the entire series has decayed 5 times, and what is produced is 3 alpha particles and 2 beta particles, okay, in order to achieve stability. Okay, and even then, we don't really know whether this radon 226 is actually already stable. We just assume that it's stable. Okay, but we never know whether it's stable or not. All right, next. Uranium-238 emits an alpha particle and decays into a thorium atom. Okay, state the nucleon number and the proton number of the thorium the isotope is formed. Write an equation for this decay. So let's start with this. 238, 92, 238, uranium-238, 92. The only thing we know is that it emits an alpha particle. So it's an alpha particle. Here is 4 and 2. Okay, and thorium, the chemical formula is TH. Okay, so you can actually tell me what the two numbers here are. Okay, 238, so here must be 234. Okay, and down here 92 must be 90. Okay, you can write the full equation like this, or you can write the simplified one. 23892 uranium, okay, becomes 23490 thorium, sorry, and you write the alpha over here. Either one of these is correct. Okay, let's complete this. This is a beta particle. Okay, beta particle, the top number doesn't change. Okay, and if you can't remember that, just remember the left side you plus everything together must equal to the right side you plus everything together. So left side is 210. Here is 0. So here must be 210. No? Here is 82. Here is minus 1. So how do you make this? What number is this? 82 equals to x plus minus 1. So you get x equals to 83. Okay, which is Byzantium. Okay, all right. Next one, strontium 9038 decays to yttrium 90, which is this. Okay, by emitting a radioactive particle. Let's write the equation. So 9038 strontium, okay, decays to become 9039 of yttrium plus, okay, what do you think? Alpha or beta? Obviously is beta because it is plus 1. And the number on top doesn't change, the number at the bottom plus 1. So it's a beta particle. What is a beta particle? A fast moving electron. So electron 0, negative 1. This will be the answer. Okay. What particle is emitted during the decay? Beta particle. Right? Yeah. What particle? Hold on. Yeah. Beta particle or upper high speed electron. Yeah. Okay. Either way also can. Hold on. Let me just check something. Okay. 232 thorium. Okay. Thorium 232 decays to become, what is this? 208. Okay. Plumber. By emitting alpha particles and beta particles. Okay. This is a very common question. How do you make 23290 thorium to become 20882 plumbum with a series of alpha and beta particles? We don't really know lah, but this is where you figure things out as you go along. Okay, and because I'm running out of time, okay, I'm just going to show it to you lah. Okay, so how many heliums and how many electrons are there? Okay, so what you can do is you can have 232 equals to 208 plus 4x, and then you will get x equals to 6 alpha. Okay, 90 equals to 82 plus 2x minus 1y. Okay, so you form the two equations. Okay, when you form the two equations, then you can get 4 beta. Okay, and that's how you do this lah. Okay, so just take the top 232, 208, and then yeah. Why is there no y? Why is there no y? Because 0 times y equals to 0 lah. Okay, so that's why kita ambil nombor di atas to find the x. Okay, kita ambil di bawah to find the y. Of course, you have to substitute the x inside lah. Okay, in order to find the x. In order to find the y. Okay, number 8, same thing. Okay, so 238U all the way become 20682 PB. So use the same method again. Okay, this is the final one lah, kan? But we need to know how many heliums and how many electrons are produced. So form the two equations. 238 equals to 206 plus 4x plus 0 times y. So you get 4x equals to 32, x equals to 8. Okay, and then after that, form the equation at the bottom. 92 equals to 82 plus 2x plus negative 1y. And when you calculate that, you get 6 beta. So there are 8 alphas and 6 betas that are produced 14 times their decay. Baru dia menjadi stabil. Okay, so it's possible. You can have 14 times. In this case, it's 10 times. Okay, so this is by far, okay, the easiest way to solve this lah. Okay, form the two equations according to the chemical equation. Okay, so what is the proton number and the nuclear number of the lead isotope? This one. Okay, again, form the equation. 238 equals to A plus 32, okay, plus 0. You get A equals to 206. At the bottom, 92 equals to Z plus 8 times 2 plus 6 times negative 1. Okay, and you get Z equals to 82. Use this is quite simple mathematics lah. Okay, just how to calculate this. All right, same thing. Alpha and beta particles are produced, yada yada. So you form the two equations again. Okay, and you find that after a while, this kind of question is like, senang saja Pak ini. Okay, so persamaan serentak saja. Okay, so you get x equals to 4 and y equals to 10. Okay, most important thing is form the equation using the top numbers and form another equation using the bottom numbers, but don't forget to include the x and the y in, because these are numbers. How many heliums and how many electrons are produced. Okay, question 11 is the same thing, also the same. So form the two equations. You get x equals to 3 alpha and y equals to 4 beta. So 7 decays altogether. It's 14 decays. Oh my word. Okay, sometimes the question, this is the last one now. Sometimes the question will give you graphs like this. Okay, where they show you the number of neutrons and against the number of protons, or in this case, the number of nucleons and the number of protons. Now, what you need to remember is that if the number of neutrons, if the number of protons are decreasing, hold on. Yeah, if the number of protons are decreasing, kan, 84 jadi 82. There's only one situation where the number of protons decrease, which is alpha decay. And this one, the number of protons is increasing. And 82 become 84. Number of protons increase means beta decay. And then the number 3 is also the same lah. Okay, it will also be alpha decay. So everything, look at the number of protons. If the protons are decreasing, then it is an alpha decay. If it is the protons are increasing, dia meningkat, okay, then it is a beta decay. Okay, so same thing. Okay, what is the number of the alpha particles and beta particles emitted during this process? Okay, so this one is decreasing bahkan 92 to become 90. Okay, kalau alpha decay dia akan kurang berapa? 42 kan, dia akan kurang 2. So this is alpha. Lepas itu dari sini 90 pergi 92. Okay, it is increasing by 2 proton numbers. That means this will be 2 beta. Okay, this one 92 pergi 90 and then 90 pergi 88 is 1 alpha here and 1 alpha here. So altogether there are 3 alpha decays and 2 beta decays. Okay, which is what you see over here. Okay, so in our next class, which is tomorrow, okay, we are going to look at half-life lah, okay, which is the second part for this subtopic. All right, everyone.